if a person is moving inside the rain, how we can protect from the rain by using of the umbrella. See, that are the cases depends upon the direction of the rain velocity and the speed of the person. Direction of the rain velocity and speed of the person. Now I am taking one case. First case I am taking. If the rain is falling vertically with VR. Now the rain is falling vertically with a velocity VR. Now the rain velocity is VR. It is falling vertical direction. The rain is falling vertical direction. Next situation, the observer is moving with a velocity Vm. Now a man is moving with a velocity Vm. The man is moving with a velocity Vm. Isn't it? Now we have to write here the velocity of the man with respect to the rain. The velocity of the man with respect to rain equation. First I am writing velocity of the man with respect to rain is equal to Vm minus velocity of the rain with respect to man is equal to velocity of the rain minus velocity of the man. Velocity of the rain with respect to man is equal to velocity of the rain minus velocity of the man. Velocity of the rain minus velocity of the man. See here minus Vm is here, but this direction we are considering as a positive. So to satisfy this condition, just we are writing here minus Vm, opposite direction I am taking. This is velocity of the man. This is nothing but a velocity of the man. So the rain is falling vertical direction, and man is moving for horizontal direction along this direction. Now to protect from the rain, in which direction he has to keep the umbrella? To protect from the rain, in which direction he has to keep the umbrella, that we are situation. And also one more, when man is moving along this direction, how the rain appears to be? If the man is going, I told you, the rain velocity, depends upon the speed of the person. If the speed of the person it is, less speed only is going, the rain velocity, for example, it is appears to be like this. If he increases the speed, it is appears to be in another direction. The rain it is appears to be in another direction. So the rain velocity is depends upon only the speed of the person. So I am writing here the resultant of these two is nothing but along this direction. The rain. This is nothing but a velocity of the rain with respect to man. Actual rain is moving, the rain is falling vertically downward. The person it is moving along this direction. But when man observe the rain, it is appears to be falling inclination direction. It is falling inclination direction. So to protect from the rain, he has to keep the umbrella with an angle of alpha. See here, if the person is standing here, to protect from the rain, he has to keep the umbrella at an angle alpha, and this is making an angle. If the rain velocity with respect to man, that is nothing but a actual velocity, this one, it is making an angle is beta. Umbrella it is making an angle with the horizontal, it is alpha. Umbrella direction is making an angle with the vertical line, it is the beta, isn't it? Here tan alpha is equal to, you can write it is, what is tan alpha? Opposite side by adjacent side. Here opposite side it is VR, adjacent side it is VM. Then cos alpha is equal to, it is nothing but the adjacent side divided by hypotenuse, velocity of the rain with respect to man. And sin alpha is equal to, what you can write sin alpha? Opposite side by hypotenuse, that is velocity of the rain with respect to man. Now this velocity of the rain, the umbrella direction with a vertical, it is making an angle beta. So at that moment tan beta is equal to, you can write tan beta is equal to opposite side by adjacent side. Here opposite side it is Vm divided by Vr, and cos beta is equal to adjacent side it is the Vr, adjacent side it is VR, hypotenuse is VRM, and sine beta is equal to opposite side by hypotenuse Vm divided by VRM, isn't it? So when person is moving horizontally, if the rain is falling vertical direction, how the resultant, the rain it is appears to be person means that is inclination direction, that is along this direction, isn't it? This is nothing but a velocity of the rain with respect to man, isn't it? This is the first case. About this, the first case. When a person is moving with a velocity Vm1 relative to ground towards east, and the rain is falling with a VR relative to the ground by making an angle theta with vertical. At that moment, we have to calculate what is the beta. What is beta means? Angle made by the umbrella with vertical. Angle made by the umbrella with vertical, that we have to calculate in this situation. See here, according to this one, man is moving with a velocity Vm1. Man is moving with a velocity Vm1 relative to the ground towards east direction. Towards east direction means, you know very well, this is north and it is east. See, a person is going along this direction. A person is moving towards east direction with a speed of Vm1. This condition, two lines are satisfied with this line. Okay, next one. The rain falling with a VR. The rain is falling with a VR relative to the ground and making an angle theta with the vertical. See here, a rain is falling along this direction with a speed of Vr. The rain is falling with a speed of Vr, and it is making an angle. It is making an angle with a vertical. It is theta. With a vertical it is theta, isn't it? Now, if the man is, we know very well, Vm1, that direction means we know we are taking every time it is the minus Vm1. So, and it is appears to be, the rain appears to be coming along this direction. So, this one we are writing as a Vr1. This is nothing but a velocity of the rain with respect to the man. This is velocity of the rain with respect to man. Now the person it is moving along this direction. This is nothing but a minus Vm1. If it is along this direction is positive, along this direction is the negative. So that's why minus Vm1. Okay. Now from here to here, I have written it is total. This is nothing but a from this point I am taking it is total. This is the x, and this one it is the vertical. I am writing as a y. This x and y are the unknowns. X and y are unknowns. These are unknowns involved. Unknowns involves in the problems. So that's why we are writing. And this part is total. It is x, and this part it is the Vm1. And what about the remaining part? The remaining part is x minus Vm1. The remaining part is x minus Vm1. And once again I want to tell here, the man is moving with a speed of Vm1. The rain it is appears to be coming along this direction. Actually, the rain it is moving along this direction. But when man is moving with this speed, with this particular speed, the rain it is appears to be along this direction. So this angle made by this one it is the beta. To protect him, he has to keep the umbrella. See here, this is the person position. He has to keep the umbrella. Isn't it? With the vertical line is nothing but a beta. With the vertical it is nothing but a beta. So tan beta is equal to, you can write tan beta is equal to opposite side by adjacent side. Here opposite side it is x minus Vm1, and adjacent side it is y. This is the tan beta formula. Beta means, once again I am telling, beta means angle made by the umbrella with vertical. Isn't it? That is tan beta. when person is moving along this direction, rain is falling along this direction. But when man is moving with particular speed, the rain it is appears to be along this coming along this direction, not along this direction, isn't it? This is the case. At that moment, to protect himself from the rain, he has to keep the umbrella. Along this direction at making an angle beta with vertical. That is formula is this one. When man is speed up at a particular velocity Vm2, the rain falls vertical. Actually, in the previous case when you observe, when person is moving, the rain it is coming along this direction, isn't it? But when he is moving with a speed of Vm1, the rain it is coming along this direction. Isn't it? Now, in this situation, same situation, but the speed is increased. Now, I am writing here, the man is Vm2. Now, the speed of the man it is Vm2, isn't it? The rain it is falling along this direction. Rain it is falling along this direction, isn't it? But now the rain it is appears to be falling vertically downward direction. Velocity of the rain with respect to man is nothing but the velocity of the man. See here, this one you can write as a minus Vm2. See here, velocity of the rain with respect to man is equal to Vr minus Vm2. This is the simple formula. In the previous that one, that when person is moving with a speed Vm1, the rain appears to be along this direction. The rain it is appears falling along this direction. But now when person is moving with a speed of Vm2, it is appears to be falling vertically downward direction. At that moment, simply you can write velocity of the rain with respect to man is equal to velocity of the rain minus velocity of the man. This is the formula.